All right, welcome back. Today, we're cracking open what feels like a total black box for so many people: artificial intelligence. We're going to look under the hood and demystify the actual engine that's powering so much of our world right now. Let's dive in.
So let's just start with the big question, right? You hear about these insane AI breakthroughs constantly, but how is it actually solving problems that have stumped the smartest people on the planet for like 50 years? What is happening inside that box? Okay, just think about this for a second. AlphaFold. For decades, 50 years, figuring out how proteins fold themselves into these crazy 3D shapes was one of the biggest challenges in biology. And then an AI just did it. And look, this isn't just some abstract science problem. This is a total game changer for designing new drugs, for understanding life at its most fundamental level. That's the kind of power we're dealing with here.
So, what is this secret engine? Well, it has a name: deep learning. This is the heart, the absolute core of nearly every powerful AI system out there today. And the main idea? It's all about using these huge, complex networks that are kind of inspired by the human brain. They learn these really intricate patterns straight from data, which means you don't have to sit there and program every single rule by hand. Okay, so that name, deep learning, it sounds super complex, right? Kind of intimidating. But what actually makes it deep? Well, the answer is way simpler than you'd think. Deep just means more layers. That's it. Think about it like a brain with tons of layers of neurons. The first layer might see simple lines and edges. The next layer combines those into shapes. The next combines shapes into, say, an eye or a nose. And by the time you get to the deepest layer, it can recognize a whole face. More layers just means it can learn way more complex stuff all by itself. Okay, so we've got this layered network, but how does it actually learn? How does it go from being a totally blank slate to, solving something like protein folding? Well, it all comes down to the learning process, and it's basically a masterclass in trial and error. And you know what? The way it learns is something we can all understand. It's a lot like teaching a little kid to recognize a cat. You show them a bunch of pictures, right? They point and say dog, and you gently correct them. Nope, that's a kitty. The AI is doing almost the exact same thing, just millions of times faster. So this whole cycle is what we call the learning loop. Here's how it works. Step 1, the network makes a guess. Is this a cat? Step 2, it checks the answer and measures how wrong it was. Oops, I was 80% sure it was a dog. Now, here's the magic. Step 3, it sends that "you're wrong" signal backward through all those layers. This is the famous backpropagation. It's like a memo going out that says, hey, everyone who contributed to that wrong guess, tweak your settings a little. And then step 4, it adjusts itself to do better next time. It does this over and over and over again, millions of times, getting a tiny bit smarter with every single loop. Now, it's super important to get this next part. Deep learning isn't just one magic tool that does everything. Not at all. It's more like a giant toolkit filled with all these specialized instruments. And each different tool, or what we call an architecture, is custom built for a very specific kind of job. So let's meet the big 3 specialists in this toolkit. First up, you've got your CNNs. Think of them as the visionaries. They are brilliant with anything visual: images, medical scans, you name it. Then there are the RNNs, the storytellers. They're all about sequences, where the order of things really matters, like understanding speech or predicting the weather tomorrow based on today. And finally, the ones you've been hearing so much about, transformers. These are the language masters. They're the absolute powerhouses behind the smart assistants and chatbots we use every day. So to make this a little more real, let's zoom in on those visionaries, the CNNs. Imagine one of these looking at a medical scan, like an MRI. It can detect these incredibly subtle patterns that might signal the very early stages of a disease, patterns that are sometimes literally invisible, even to a highly trained doctor. It's like giving doctors a superpower. And the accuracy these things can achieve is just wild. Think about something as simple as mailing a letter. How do they sort millions of them every day? Well, that's a neural network that has been trained on mountains of handwriting samples. It can read even the absolute worst, messiest handwriting with over 90% accuracy. It's the perfect example of a highly specialized AI just absolutely nailing its one job. Okay, so all of this technical stuff, it brings us to a really important pivot. We have to move from the how to the human side of the equation. Because once you understand how these systems learn, you have to start asking a much bigger question.
What is our role in all of this? What's our responsibility?
And this next point is absolutely crucial. An AI learns from the data we give it. That's it. So if we feed it data that's full of our own historical biases, whether that's in hiring decisions, loan applications, you name it, the AI isn't going to magically become fair. No, it's going to learn those biases, and worse, it's going to amplify them, baking them into its decisions at a massive scale. And that right there is why we needed to open up this black box in the first place. Understanding that AI learns from examples, that it's constantly correcting itself based on errors, and that it is a direct reflection of the data it's fed, that knowledge is the absolute first step to building responsible AI. This isn't just a conversation for programmers anymore. This is for all of us. So we've peeked inside the black box. We've seen the nuts and bolts of how these incredible systems learn. The technology itself is brilliant at one thing: getting smarter. But that leaves us, it leaves you, with the most important question of all. We've figured out how to teach an AI to be smart, but who is going to teach it to be wise?